So good afternoon, everybody. So now I am making the second video for the project. Okay, let me do something here before we start. Yeah, we have something here. Okay. So let me maximize this one. Okay. Let me turn this one off. Okay. So as you know, our the project has two parts. The first part is the generator, and you should have done this part. Okay. Today I'm gonna explain the second part, which is a detector. So as you see here, we need to design a logic circuit that accept a sequence like A0, A1, 2 bits. So every time it's 2 bit by 2 bit for a sequence, and then it has to tell me if this is sequence number 0 or sequence number 1. That's why you call it sequence detector. I encourage you before you try this part of the project, you need to fully understand this slide. So you already have recorded videos. I already explained it. So in this slide, I'm explaining a sequence detector, but we have only one input here. Okay, so the idea is very close. If you can understand this one very well, you can do our detector here. But you need to keep in mind there is one main difference. This is sequence detector, that's true, but it's only one input. Here we have two inputs. That's it. So there is just a small difference. Same thing also, this example, I explained it in the lecture. So you need to study these two examples, okay? You have the recorded video just in case you want to go back. I strongly encourage you to understand these two problems before you try this detector. So here, if you go to the project description, so yeah, that's what I'm telling you here. You have we created two sequences, as you see here. This is from the generator. This sequence is a sequence number 0, which is generating numbers in binary. This is what we call gray code. So this is sequence number 1. So the generator is going to generate either sequence number 0 or sequence number 1. Okay, we have two output here. If you generate sequence number 0, the detector has to tell me this how. So it's going to be like 1 0. If you generate 1, so it has to be 0 1 this way. Okay, I encourage you to connect LEDs here, so that if I see this LED on, that means sequence number 0 is detected. If I see this, the second LED is on, that means the sequence number 1 is detected. Okay. Yeah, that's what I'm explaining here. So the output of the detector should be 0 0 when no sequence is detected. Detected should be 0 1 when one sequence is detected. It's a sequence number 0. It should be 1 0 when sequence number 1 is detected. Yeah, the project should work this way. If S is 0, okay, so the generator should generate sequence number 0, and the detector should detect that and should give you this output 0 1. However, if you select the input S is equal to 1, so the generator should generate sequence number 1, and the detector has to detect this one, and you should see 1 1 0. Okay. So here, yeah, so here I'm telling something really very important. I understand this project is somehow complicated to do it in one board, in the board. That's why what I'm gonna do is, and that's what I told the TAs, because the circuit is somehow complicated, you don't need to implement this circuit. Okay, if you want to implement it, that's totally fine. So my original plan was, and if you can do it, it's okay, it's totally fine. My original plan was, if number one, if you wanna physically implement both of them, the generator and the detector, okay, I'm totally fine. But I am afraid you may not have a space on the breadboard, and I'm afraid it's going to be too complicated. And it's not big deal for education because you already know how to do it. You got what I'm saying? What's really important here in the project is to learn how can you design generator and detector. Implementation wise, we already had several labs about this. Okay, so the first option you have, you can implement everything. Okay, maybe a little bit complicated. The second option we have is you can use is a discovery kit to emulate one circuit, like for example the generator, and then you can physically implement one of them, like detector. So you can physically implement one, and then you can virtually use virtual circuit for the second one. Okay. The third option, and then again, I'm totally fine with this one, just to do simulation using digital. So if everything using digital simulation, I'm totally fine. You will get full credit. That's what I told ZTEs. Okay. So let's see now. Let's return to the problem we have here. So number one here, you need to draw the state diagram. This is the first step for sure. After you draw the state diagram, you need to make the state table. Okay, that's it. Once you have the state table, you need, similar to the two examples you have, you need to implement the circuit itself. You can implement. You can use D flip-flops. Okay, to make it just easy. So let's start with the. Then here I'm asking you to use the parts to make the connection. Yeah, you just draw the circuit. I'm totally fine with this one. Yeah, so here instead of implement, you can make it simulate. So, or let me say it in a different way. Implementation here can be physical implementation, or it can be simulation. I'm totally fine. Okay, so let's start here with the first part here, because this is the most, as I told you in lecture, this is the most important part, how to make a state diagram. Once you have the state diagram, it's very easy to translate to state table. Again, I'm repeating it for the third time. I strongly advise you to revise these two examples. It's not going to take much time from you. It's just very few slides. Read the slides, see the video. Okay, all the lectures are recorded and posted in the course website. Okay, you need to learn these two examples even for the final exam. I promise in the final exam there will be a question related to the design of circuits. Okay, so that's why you need to be prepared for that. If I give you a problem, how can you design a state diagram? Okay, so anyway, so now let's do it here. Okay, so as you know here, we have two sequences. Let me write them down because I forgot them. So here, I think, let me see. So we have 0, 0, and then after 0, 0, we have, I guess, 1, 0, and then after 1, 0, it should be 1. Sorry, I'm sorry. Let me delete everything again. So the two sequences we have, sorry. Okay. Delete everything again. So the number one is going to be 0, 0. After 0, 0 should be number 1, and then because this is binary, so number 2, and then number 3. After 3, you are going to go back to 0, 0 again, and this is actually sequence number 0. For sequence number 1, 0, 0, and then this one is 0, 1, and then after that, this one is 1, 1, and then this one is 1, 0. Okay, and this is sequence number 1. And by the way, just I want to repeat. I already said it before, but just I want to repeat it. This sequence, we call it gray code, because if you see the difference between every two numbers here, it's the difference is only in 1 bit. So here, from here to here, we just changed 1 bit. From here to here, we just changed 1 bit. From here to here, we only changed. This is a gray code. Okay. So now this is. Let me make sure. I'm sorry, but I'm very positive. Yeah, this is the first sequence. This is the second sequence. Okay, just I want to make sure it's correct. Anyway, so you can observe, there is an observation here, guys. You can see this part is common between both of them. Okay, so let's I'm gonna, for sure I'm not supposed to solve it, but I will give you some idea how can you solve it. Okay, so here I'm gonna assume we have an initial state. I'm gonna call it SC0. So this is initial state. And then usually the easy way to do it, guys, to see if you have the sequence. This is the first thing you can do. If you have the sequence, how it should behave. Okay. So first I'm here in the initial state. So if the input is actually 0, 0, so I'm gonna move to the state of S1. So S1 means 0, 0. Is that okay? And then after that, after 0, 0, okay, where we are gonna go if I receive. So I'm sorry, this is 0, 0. Okay. So okay, I'm sorry, I need to delete something here. Let me use the eraser, okay? Because I just want to need a space at the top because I'm gonna use it. So let me put it down here. I'm gonna do it again. Okay. So here, yes, we have here S0. Okay, this is the initial state. So once we receive 0, 0, so I'm gonna move to state number 1. In state 1, so now I have 0, 0 in the sequence. Okay. Now, if after that, again, this is the way you have to do it. Okay. Number 1, you have to consider the case that you receive all the sequence. Okay. So, and then after that, I received, for example, I received 0, 1. Is that okay? So I'm gonna go to state 2. So if you come to state 2, what it means? It means I received 0, 0, and then I received 0, 1. Is that okay? So until now, this part should be common. This part should be common for the two sequences. Is that okay? Now, let's assume I'm going to do the first sequence number 0. In case of sequence number 0, so after S2, okay, I'm going to get here 1, 0. So if it is 1, 0, if I receive 1, 0 here, so I'm going to come to state, I'm going to call state number 3, 1, 0. So if I come to this state, that means I already received 0, 0, and then 0, 1, and then 1, 0. Okay. Okay. Finally, if you here and then you get 1, 1, you get 1, 1. Assume, just to make the problem is very easy, assume there is no overlap. So you have to receive this exact same sequence. There is no overlap between sequences. Okay. So that after that, if I receive 1, 1, so now I got the complete sequence. Okay. I forgot to see what should be the output. So here the output is 0. Here the output is 0. I'm sorry. We have here the output is actually 2 bits. So here the inputs are 2 bits. The outputs also 2 bits. Here 0, 0, and here also 0, 0. Here the output should be 0, 1. Why? Because I detected the first sequence. Okay. So you can see here again, guys. Here, this is the initial state. When I receive 0, 0, I'm gonna come here. If I come here, that means I have 0, 0. When after that, when I receive 0, 1, so I'm gonna come to here. So when I come here, so I already have 0, 0 and 0, 0, 1. Keep in mind, this is a common part for the two sequences. So now this part from here to here, this should be sequence number 0, the first sequence. Okay. So if I receive 1, 0, so I'm gonna come here. So if I come here, that means I already got 0, 0, and then 0, 1, 1, 0. And now if I get 1, 1, so I have to come here and the output has to be 0, 1. So you can observe here, guys. Maybe I want to use a different color. Yes, I need to use a different color here. So you can observe here. Let me use if. Okay, I'm not sure if you can see it or not, but yeah. If I move this way, this should be sequence number 0. Okay. So now what happens is, yeah. Okay, what happens here after you come to SC2, so now I'm gonna consider sequence number 1. Okay. So after I come to S2, after I come to this one here, now I received 1, 1. It not 1, 0. If it is 1, 0, I'm gonna come this way. Now I'm gonna assume I'm gonna receive here 1, 1, 1. Okay, because it is 1, 1. So now I'm gonna make a new state. I'm gonna call it S4. Is that okay? So if I come to this point, that means I already received 0, 0, and then 0, 1, and then 1, 1. Is that okay? Okay. After that, if I receive here 1, 0, so I'm gonna move again to the initial state, and here in this case I'm gonna make it 1. The output is 1, 0. Here the output is 0, 0. So that means here I detected the sequence number 2. Number 1. So what I want to tell you here is, or what you should understand it here is, if if I come here this way and then I come this way here, okay, that means this is should be sequence. This is sequence number 1. Okay, now, and this one is actually, let me go back to here. This is sequence number 0. Sequence number 0. Okay, so I will come this way and then come this way. Okay. Okay, guys, is that clear? Now, so are you done? Have you finished? No, because for every node we have here, you have to consider all possible cases. What I did right now, and this is how you solve these problems. You start with if you have the correct sequence. Okay, so I did it here one time. If I have the sequence 0, what have the sequence 1. So now you have to return. Let me erase something here. So I want to erase this one here. Okay. Also, oops. Okay, let me see. Control Z. Looks like Control Z is not working, but that's okay. So what I'm gonna do here is okay. I just removed this one here. Okay. So now look here, guys. The idea is that for every node you have to consider all possible cases, and because we have 2 inputs, so for every node you should have 4 cases. So for every node I can have 0 0. Is the input can be 0 0, or it can be 0 1, or it can be 1 0, or 1 1. So you have to consider all possible cases. For example, I'm going to use different color just because. I'm going to use a different color just because. Oops. Okay. Just because just this one here, this is the case when you have sequence 0, sequence 1. Okay. So let's for example consider this case S0. So for S0, maybe the input is 0 0. Is that okay? Maybe so 0 0 is already done. So now you need to think about the other ones. How's it? So if you are here in the if you are in the very beginning and then you get 0 1, or you get 1 1, or you get 1 0 1 1, what should you do? Okay. Should I start to go this way? No. So what happens here? I have to loop back here. In order to start the searching for these 2 sequence, I have to get 0 0. If you get anything else other than 0 0, you have to loop back to here. So now I can see we have here 0 0, 0 1, 1 0, 1 1, and the output here has to be 0 0. For any other case, so the only way, this is the initial case, the only way to move this way to start searching for sequences is by receiving 0 0. Is that okay? So I want you to repeat the same thing for the other. So now I get this one completely done. If you look here at S1, I consider to here only one case when it is 0 1, when the case of 0 1. Okay. Now what happens if you get 0 0? What should you do if you get 0 0? Okay. What should I do when I get 1 1 or I get 1 0? Okay. Maybe I'm gonna solve this one as well, but I'm gonna leave the rest for you. Okay. For example, if I come here, I already received 0 0. What if I receive 0 0 after this one? What should I do? Okay. So I have to loop back to here. Okay, so that I'm gonna start the searching from this one here because I already have 0 0 in hand. What if you receive anything else? So after 0 0, for example, you got 1 1. So I have to go back to the initial state again, so that I'm gonna look for 0 0 again because I broke the sequence now. Okay, so this is in case of 1 1. What if I receive 1 0? It's the same thing. I have to go back here. Okay. Let me do one more, but this is the last one. Okay, I shouldn't give you all this information, but because this is somehow again, you know me, I don't want to use the word hard, but I won't help you here on this one. Okay, anyway, but I'm gonna do this one and then I'm gonna leave only 2 for you. Okay, so if I come here, let's see here. So here I already did. If you have 1 1, so 1 1 is done. I did 1 1. I already here I did 1 0. Is that okay? So if you come here, that means I already received 0 0 and 0 1. Is that okay? So I already finished 2 cases. I still have 2 other cases. It may be 0 1. It may be 0. It may be 0 0. It may be 0 1. Okay. Let's think about it. If I get 0 0, what should I do? Okay. Now I broke the sequence. Okay, so I have to, so this one has to go back to here, so that I'm gonna look starting from 0 0 again. I told you there is no overlap. I have to find the whole sequence, and then the same sequence has to be repeated again. There is no overlap between the two sequences. Is that okay? So if it is 0, 0, it has to come back to here because I have 0, 0 in hand. What if you receive 0, 1? So after 0, 0, you got 0, 1, and then 0, 1 again. What's going to happen? Okay, so now I have to go to the beginning again. I have to go to the beginning again just to look for 0, 0 to start searching for sequence. Okay, I think this is more than enough. So what you have to do here, number one, you have to finish this state diagram. After you finish this state diagram, so now I want you need to make the table, state table, and then once you have the state table, you need to find the equations, the input. You need to find the input equation of the flip-flops. We're going to use D flip-flop. Okay. Also, you need to find the equation for the output. Remember, in the output we have two outputs. Okay. So let's start with the first one. So what you have to do, guys, similar to the examples you have. Number one, you need to complete this state diagram. I already solve one. So how many states you have here? 1, 2, 3, 4, 5. You have 5. I already give you 3. Only similar to what I did, you have to do for the other 2. Again, for every node, you have to consider the cases. Okay. If you get this input, so I have to go here, 1, 0. What if I get 0, 0? What if I get 0, 1? What if I get 1, 1? So you have to consider all possible cases. Okay. And for everyone, you need to tell me what is the output. So here, and remember, because in this case we have 2 inputs and we have 2 outputs. Okay, so that 2-bit input and 2-bit output. That's why you see here the format you have to do it as I did. For example, 0, 0, 0, 0. That means if this is the input and there should be this is the output. Okay. So anyway, I think this is more than enough for this one. So now you can see how many sequences I have here. Okay, so you can see I have 1, 2, 3, 4, 5 states. So now because I have 5 states, so the first question you need to ask yourself, how many flip-flops I have to use? Okay, can I use 2 flip-flops? The answer is no, you can't. They are not enough. Why? Because 2 flip-flop can give you up to the power of 2, which is 4 states. But here we have 5 states. That means I have to use 3. I have to use 3 flip-flops. Wait a second. 3 flip-flops should give you 8 states. Yes, 8 states. So, however, I need only 5 because if you go back here, I have here 5. Yeah, that's okay. So what I'm gonna do, I have 8, but I'm gonna use only the 5, and the other ones, as you will see right now, should be don't care. So as you will see right now, they should be don't care because they will never happen. So as you will see right now, so the other ones here should be don't care, and that's good because it can simplify them. Okay, so now let's see how can we do the state diagram based on what you have here. So in the state diagram here, as you know, the way you do state diagram, I'm going to use 3 flip-flops. So I'm going to here we have A, we have B, we have C, 3 flip-flops, and also we need to put the inputs here. I'm going to assume you have A1 and A0. This is the 2 inputs I have. Okay, this is the 2 inputs. All what you have to do here, you have to write all possible cases. Is that okay? So here in the all possible cases, you have to put here 0, 0, 0. Yes, there should be 16 0, 16 ones, 16. And then you have to put here 1, 1, 1, 1. Okay, all the way you should be 16 ones. Okay, here should be 8 zeros, 8 zeros, and then 8 ones, 8 zeros, and then 8 ones. Is that okay? You know that. Then here 4 zeros, 4 ones, 4 zeros, 4 ones. That's okay. For A1 here, should be 2 zeros, 2 ones, 2 zeros, 2 ones. For this one here, 0, 1, 0, 1, 0, 1. Okay, so this one actually all possible cases we have here. Okay, so this is the input. This is the state, the current state. So here, these 3 here are the current state, and this is the input. This is how the state table looks like. Okay, what about the output here? So here I should have the next state ABC, but these are the next state. Okay, and also I should have the output, which is actually D1 and D0. These are the output. Is that okay? So now, okay, so I already did this part. So we need to fill up these parts, these 2. For sure, if you understand the examples you have, you will see it's just very easy to fill up these 2. all what you have to do, just you have to go to from the diagram. So you have to use the diagram to do that. Okay. So let me, for example, give you one example here, because this part should be easy. The most difficult part is how to make the state diagram. Okay. So for example, if you look here, guys, if I'm in state 0, 0, by the way, I need to define, because here I didn't define, I set state 0, state 1, and so on. I didn't define these states. Okay. So in binary. Okay. So you will see what I mean right now, but let me delete this part here. So now in the beginning, you can just use names like state 0, state 1, like what I did right now. But now I need to get numbers. Okay, so what I'm going to do right now is, guys, I'm going to say, because now I know I need 3 flip-flops. So state 0 means it's going to be equivalent to 0, 0, 0. Is that okay? State 1 is equivalent to 0, 0, 1. State 2, this is ABC. Okay, so if the flip-flops ABC, okay, whatever ABC, if the flip-flops are 0, 0, that means I'm in state 0. Okay, state number 2 should be 2, right? State number 3 should be number 3, which is this one. Sorry, yeah, this is 3. No, sorry, this is 3. I'm sorry. State number 4 should be 1, 0, 0. So these are all the states we should have. This is ABC. That's why if you go to the table here, yeah, so if you go to the table here, you only need to focus on 0, okay, as we see here, 0, 1, 2, 3, 4. What about the rest? Because we still have here 5, we have 6, we had 7. Is that okay? 5, we have here 0, 1, 2, 3, 4. Okay. After that, we have 5, 6, 7. Is that okay? These ones should, yeah. So in all these cases, okay, they should be don't care, because they are not going to happen, because I'm going to use only 5 states out of the 8. Is that okay? So that's what I'm going to do right now. So now I'm explaining now, using the state diagram you created, how can you fill up here? This part is here. Very simple. All what you have to do, guys, is now if I'm in state in 0, 0, 0, okay, which is state 0. This is state 0. So if I'm in this state, okay, and the input is 0, 0, what should be the next state and what should be the output? This information you can find in the state diagram. So if I go to the state diagram, you can see here, if I'm in state 0, okay, and the input 0, 0. So what should be the next state? It has to be state 1. I have to move from here to here. So that's why here I'm going to say it is 0, 0, 1, state 1. Okay. And what is the output? 0, 0. Again, you can find it here. Yeah, you can find it here. Is that okay? I can do one more or a couple more. So now if I'm 0, 0, 0, if I'm at 0, 0, 0, okay. And now the input is 0, 1. Okay. So if you see here, I'm saying what I'm saying, if I'm 0, and if I get this input or this input or this input, I'm sorry, this is not 0, I'm sorry, this is a mistake, okay? Because I already used 0, 0 this way, okay? 0, 1, 1, 0, 1, 1, okay? So if you get any one of this case, the output should be 0, 0, and the next state is also S0, okay? So what I'm gonna do here, yeah, so here in the coming 3 cases, yeah, these are the 3 cases we have here, okay? So in these 3 cases, when the input is 0, 0, 0, 0, 0, 0, but at different values here, like 0, 1, 1, 0, and then 1, 1 in these 3 values. So the next state should be 0, 0, 0, 0, 0, 0, 0, 0, 0, and the output actually is 0, 0, 0, 0. Okay. Anyway, so this part should be very easy. You just fill up the table based on what based on the diagram you created. Again, you have to be very careful, because the problem is in such questions, if you make a mistake here, everything after that will be wrong, okay, or there will be a mistake after that. So you need to be careful when you do this. Once you do this one, again, it's just very easy to fill up this one. I give you one case, okay, but now this is what you should learn. When I come to this case here, starting from 101, okay, 101 is starting from state number 5, okay. So you can see here we have every number here is repeated how many times? 4 times because it's going to be 101 and then 101 and then 101 and 101. Okay, and here you are going to get here 00 and then you're going to get here 1 or 2 and 3. Okay, so for every state, here you are going to see it in the table. It is repeated 4 times. Why 4 times? At 4 values here for E0 and E1. Okay, so what you have to do here is starting from this state and next here, or all next states, because this is not going to happen. We have until here. So here you have to use don't care. That means, yes, the table looks big table, but actually it is not. Oh, sorry, it's only 2. Okay, it's not, because once you come to here, you didn't need to calculate anything after that. Why? Because it's don't care. We're not gonna use this case 101. It's not gonna happen because yes, I have 8 states. I can, because I have 3 flip-flops, I can go to up to 8 states, but all what we need here, we need only we are going to use only 5 states, starting from state 0, state 1, state 2, and state 3. Every state you can see it repeats 4 times. So that means all what you should have, again, I told you, you have state 0, state 1, state 2, state 3. That's what you have to calculate. This one is going to be 4 rows, 4 rows, 4 rows, and 4 rows. Is that okay? So total 1, 2, 3, 4. So total you need to calculate 16 rows. Okay. What about? Let me check. Just I want to make sure very accurate about this. So you have here 0, 1, 2, 3. I'm sorry. You need also 4. I'm sorry. Yeah, I forgot 4 because we have 5 states started from state 0 until state 4. If I go back here, yes, we have 0, 1, 2, 3 until 4. So yes, so actually we have 4 rows here. So all what you have to calculate, 20 rows. Okay, and then after that you are gonna have state 5, 6, 7. Total, they should be how many? Everyone is gonna be 4 times. Should 4 rows. Every one of them 4 rows. Okay, so it should be 12 rows. These 12 rows. Okay, for the output here, they are gonna become don't care. You don't need to calculate them for the output. For the output here, just to put don't care. Okay, so all what you have to do, based on the state diagram you have, you need to calculate 20 rows here. Okay, 4 rows for zeros. Okay, let me. I'm not sure if what I'm explaining here is clear, but okay. So I can. Let me make it in a better way. I'm gonna explain it. A, B, C, D. Okay. So, sorry, ABC and then E1, E0. Okay. So what I'm saying, guys, is that if you have here 0, 0, this is state 0. You will find this state 0 is repeated 4 times. When you put all possible cases, you will find it is repeated 4 times. Is that okay? When this one is 0, 0, when this one is 1, when this one is 2, when this one is 3. Okay. And then to fill up this part, you can find here for every state, you need to go to this state if you are in state 0, 0. Okay, in state 0. If you are in state 0 and this is the input, what should be next state and what should be the output? You can easily to get this information from the table. Same thing for this one. Same thing. You have to go all the way until you reach state number 4. State number 4, which is actually 1, 0. Sorry, yeah, 1, 1, 0, 0. This is state number 4. Okay. Yeah. And for this one, again, it is repeated 4 times. Yeah. So here we have 0, 0, you have 0, 1, you have 1, 0, you have 1, 1, 4 times. So total here, that's what I'm saying, you have 20 rows. You need to fill up these 20 rows from the state diagram. That's very easy. Now, after that, after this state, let me, okay, I don't need to delete. I'm going to tell you here. Yeah, let me use just a different color. So here, after this one here, guys, okay. So anything after that, all what you have to do, you need to put the input here, okay. But all what you have to do is just don't care. And okay, don't care, okay, because this shouldn't happen. For example, in state number 5, we don't have state 5 from 0 to 4. Okay, so in these 4 cases, you still need to consider the 4 cases. So 0, 1, 2, and 3. Okay, so for these 4 cases, you just put here don't care. Okay, and then after that, so once you finish this table, similar to what I explained in the other problems, All what you have to do is you have to take here, you have to take this column here. Let me use a different color. You need to design the input of the flip-flop, okay? For each flip-flop. So how can you get the input of this flip-flop? For example, flip-flop A. How can you, all what you have to do here, guys, you need, this is the input. I have 5 inputs, okay? You remember the lab when we used, there was a, I think it was just I think last lab or lab before. I think the lab before. So in one lab, yeah, in the verifier, when we created the verifier, yes. So I think this is lab 8. So in one lab, we had the same problem here when you have five variable and we need to use key maps to simplify them. So there is a online website. You need to go to the lab and see how we made it, or you can use digital to do it. Okay. So all what you have to do here, guys, I'm gonna take all this one, okay, and then these are the inputs here, okay, and then I need to get this is like F1, F2, F3. So what you need to get here, you need to get what equation, what simplified version for A, okay, the simplified version for A to get A, B, C, E1, E1. So to get, so here, you need to, for example, you will get something like, let me clear this one. For example, you can say, yeah, GA, for example, equal BC prime E1, E0, for example. Okay, so that means flip-flop A, this should be the input of flip-flop A. It has to be B, C prime, E1, E0, for example. Okay, you need to do the same thing for B and C and G1 and G2. Okay, so these two called output equations. Are the output equation. Okay, and these 3 here, it's called state equations. Okay, so you need to get state equation here, state equation here, state equation here. So again, similar to what you did here, it shouldn't be difficult because you are not going to do it by yourself. This minimization, minimization should be done by the program, so it shouldn't be difficult. Okay, so you can just, yeah, take this one here, go to the website and try to get this one function A, B, C, E1, E0. Okay, that's it. Once you do that, you are done. So now all what you need, I need 3 flip-flops. Okay, this is flip-flop A, B, and then C. Is that okay? All of them connected to the same clock, as I told you. Now you already got function here, whatever this function. For example, if we assume this is correct, so for example here, so this one will be B, C prime, E prime, same thing here. You can see what is the input here, what is the output here. Also, you will get some equation for E0 and some equation for some equation for output D0 and G1. Okay, yeah, so here I'm gonna get G0 and G1 because this is the most important. This is the output, yeah. Okay, so you will get this one function in these ones, and also function in the input. You have E1 and 0. Okay, so anyway, hopefully I made it easy. So let me summarize what I said here, guys. Number one, in order to do this part, I just want to make it easy. I don't want to be too complicated and you hate the course and you don't like it. Nothing is difficult, but when you understand it, everything is okay. So here, so let me summarize what I said, guys. Number one, I encourage you to revise these two, okay? To revise these 2 examples. This is the first thing you have to do because I'm going to do the same. We're going to do the same thing like this one. Number 2, you need to, I already here explained how can you state diagram. I already did 3 out of 5. So you need only to finish these 2. Once you have the state diagram, okay, ready, you need to know how to fill up this table. And that's I already explained in lectures. How can you do that? So now you have a state table with 5 inputs. Okay. And now similar to what we did in lecture, but I think in the lecture we had only, I don't remember, is it 3 or 4 inputs, okay? I can see here. So for example, in this example, how many, we have only, the table had only 2 inputs because I need only 2 flip-flops, A and B. No, sorry, 3, because I have only also input here. Do I have input? Yeah, I have input here X. So I need two flip-flopped and one X. So it's going to be 3. But in this project, it should be, the input should be 5. Okay. It's again, all what you have to do, just similar to lab number 8. You need, once you fill up this state table, you have, for example, you need to take this one, create this and simplify using the website or digital using this input. So these are the inputs here. Okay, same thing, simplify this one. So this one should give you the input of flip-flop A. This should give you the input of flip-flop B, the input of flip-flop C. This should give you the output, okay, and another output here. Okay, that's it. Once you do it, just run it run it in digital or implement, as I told you, whatever you want. If you want to make it physical implementation, if it is hard to make it physical, I don't care. Why? Because what's really important, what you should learn here in this project is, I don't want, it's going to be very tedious to make big circuit with many wires, and learning regarding learning, you're not going to learn anything new. I care more, what I care here for learning, I care about how can you design, you understand how can you make a state diagram, how can you make convert it into state table, and then you design this circuit here, okay, and you run the simulation. So if you just, I encourage you to do that, just to do the simulation. I'm totally fine with that. You will get full credit. Okay. So I think that's it. If you have any questions, just email me and I can make another video if it is needed. Okay. So if you need another video with any clarification, just let me know. Okay.